You are listening to the Vocal Technologist. Spoken tech for your ears.
I was staring at my coffee machine the other morning, waiting for it to heat up.
Oh, yeah.
And I swear it felt like a lifetime, just staring at that little blinking light. But then I sat down, opened a browser tab to check one single email, and 3 hours just vanished in what felt like 5 minutes.
Time blindness is a very real thing.
It is funny how humans perceive time versus how computers do it.
Yeah.
You know, we stretch it and shrink it based on how bored we are, whereas a computer is just tick, 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 perfectly linear.
Well, I have to stop you right there.
Go on.
Computers are usually precise, sure. That is true, unless you are deliberately lying to them. And as we are going to see a bit later on, sometimes lying to a machine about what time it is the absolute only way to get anything done.
You always have a correction ready, do you not?
I try my best.
But I love it. That is a perfect hook for what we are getting into here. For everyone listening, you are in for a ride. We are going to unpack a massive stack of updates. We've got AI completely rewriting the rules of employment to some genuinely clever engineering tricks that bend the reality of web browsers.
It is quite the mix. We are looking at the shifting role of the developer, some truly terrifying security oversights that popped up, and the nitty-gritty of database performance that keeps the lights on.
Terrifying security oversights are my absolute favorite kind, as long as they are not happening to my servers.
Exactly.
If you are a regular here on Vocal Technologist, you know we love getting into the weeds, so let us crack on and get stuck in.
Let us do it.
I want to kick off with the big elephant in the room. There is this phrase floating around the industry right now that code is cheap.
Yes.
I feel like I'm hearing it everywhere. The idea is that the actual physical act of typing out syntax, the if statements, and for loops is basically becoming free because of AI. But is that actually true, or is it just industry hype?
It is a provocative statement for sure, but there is real truth to it. Think about it this way. For the last 20 years, a developer's value was often proxy measured by their ability to produce syntax.
Right. How fast can you write the boilerplate to spin up a server?
Spot on. AI drives the cost of that syntax down to zero. If you can generate 1,000 lines of boilerplate in seconds, the value of a developer is no longer in their typing speed or their rote memory of syntax.
So if the syntax is free, what are we actually paying for?
You pay for the decision-making, you pay for the person who knows which server to spin up, or even more importantly, knows when not to write code at all.
The human element.
Exactly. The value has shifted to what some are calling the human technology system. It is just a fancy way of saying we are moving from an economy of construction to an economy of curation.
That sounds a bit abstract, though. Does it just mean we are all managers now?
In a sense, yes. It means the focus is now heavily on quality, reliability, and architecture. It is about understanding how the pieces fit together. If code is cheap, then bad code is even cheaper, and we are drowning in it.
We really are.
The engineer's job becomes managing that chaos, ensuring the system actually solves a human problem rather than just compiling without throwing errors.
So we are moving from bricklayers to architects. But there is a very real-world impact to this economic shift. Right? It is not just philosophical. There was news about the fintech company Block, and it did not look like they were just hiring more architects.
No, you are right. Block made headlines for laying off over 4,000 people.
Which is massive.
It is roughly 40% of their workforce, a massive cut.
And the reason was not just standard restructuring, was it? Jack Dorsey did not frame those layoffs as just business as usual.
No, and that is the key point. Dorsey specifically cited that AI is fundamentally changing how they build and operate. The implication is that they simply do not need as many humans to maintain their velocity, or that they need a completely different shape of workforce to leverage these new tools.
It is a structural change in how software is built.
Precisely.
40%. That sounds incredibly grim. For you listening, it might make you wonder if this is the writing on the wall. Are all devs doomed to be replaced by a shell script and a monthly subscription fee?
It is very easy to spiral into that doom loop. But there is a strong counter-narrative out there, too. There is an argument floating around that developers are actually safe. And ironically, the very thing saving them is bureaucracy.
Good old red tape, saving jobs since forever. Is that really the argument? That we are safe because big companies are just too slow to fire us?
Essentially, yes. The argument is that corporate processes in large enterprises are glacial. It takes so long to get new tools approved, to get through rigid security reviews, to integrate things into legacy systems.
Because of that, AI adoption is actually much slower than the headlines suggest.
Exactly. The headlines say AI replaces everyone tomorrow, But the reality is AI might replace someone in 5 years once the legal department finally signs off on the procurement contract.
That feels very true to anyone who has worked in enterprise. I mean, trying to get a new software license in a big company is like trying to pass a bill in Parliament.
It really is. And this ties perfectly into a report about the 2026 global intelligence crisis.
That sounds like a spy thriller.
It does have that ring to it, but it is actually about market dynamics. The report suggests that real-time data shows AI adoption is stable. It is following an S-curve, not a vertical line.
So it is flattening out.
We are hitting physical and regulatory limits. It is not exploding out of control. It is diffusing through the economy at a very manageable pace. So while a company like Block might be cutting jobs, the broader market is not collapsing overnight.
That is heaps more reassuring. It is a transition, not a cliff edge.
Speaking of the tools driving this transition, I want to look at how we are actually using them. We have moved way past just chatting with a bot in a browser window. Now we have things like Claude Code and something called the Claude C Compiler, or CCC.
Right. The CCC is a fascinating case study. It is essentially an experiment in using AI to act like a traditional compiler. You feed it logic and it spits out C code. What the engineers found is that it is absolutely fantastic at following established patterns.
If you need standard implementation, it is great.
Yes.
But coming, I can feel it. There is always a but. It struggles heavily with true innovation. If you give it complex, non-standard inputs like messy system headers or weird edge cases, it completely falls apart.
Because it cannot invent solutions outside its training distribution.
Spot on. It is a highly advanced pattern matcher, not a genius inventor.
So it is a very fast, very well-read junior developer, but definitely not a senior architect.
That is a very fair analogy. But the interesting thing is we are getting much better at managing these juniors. There was a brilliant experiment regarding an AI coding agent called Klein. They used a technique called hill climbing.
Hill climbing. That sounds like a weekend fitness routine.
Yeah.
But in computer science, that usually refers to local optimization. Right?
Exactly. It is an iterative algorithm.
Yeah.
Imagine you are stuck in a thick fog on a mountain and you want to get to the peak. You cannot see the top, so you just take one step in the direction that goes up.
And you keep doing that until you cannot go up anymore.
Yes. So they applied this exact concept to the coding agent. Instead of just accepting the very first draft of code the agent writes, it actually analyzes the error output. It makes a small adjustment, takes a step up the hill, and runs it again.
So instead of just shrugging and giving up when it hits a compiler error, it tries to fix it itself.
Precisely. The developers took Klein and ran it against a benchmark called Terminal Bench. This consists of 89 real-world developer tasks. Initially, the success rate was about 47%.
Which is basically a coin toss.
Right. But by using this hill climbing technique, iteratively diagnosing its own failures and fixing them, it climbed the hill from a 47% success rate up to 57%.
That is a flat 10% jump just by forcing it to iterate on its failures. It really shows that these agents are not static entities. You can tune them.
Absolutely you can. And that leads to probably the best way to manage these agents so they do not hallucinate all over your code base. It is a concept called knowledge priming.
I like the sound of that. It sounds like giving someone a cheat sheet before the final exam.
It is very similar. The core idea is that instead of letting the AI blindly guess about the context of your project, you feed it a curated context file before it even starts coding.
You explicitly tell it, hey, this is our architecture. These are our strict naming conventions. This is our exact tech stack.
Exactly. You prime it with specific local knowledge. It treats that context file as the absolute overriding truth. That stops it from drifting off into generic solutions that look correct, but do not actually work for your specific code base.
It is about constraining the infinite possibilities down to the ones that actually matter for your specific environment.
Yes.
That makes heaps of sense. Do not let the robot guess. Just give it the instruction manual.
Right.
Now, speaking of things going wrong, let us pivot and talk security.
Yeah.
Because I read something about Google API keys recently that genuinely made my blood run cold.
Ah, yes. The massive oops heard around the tech world. This is a classic example of feature creep completely creating a vulnerability.
Unpack it for us. What exactly happened?
So for years, Google API keys were treated as public identifiers. They were completely benign. You could put them in your client-side front-end code, and it was fine. They were just used to identify the application, not really to secure secret data in a high-stakes way.
Like a public name tag. Hello, my name is app number 5.
Exactly. But then came the Gemini integration. Suddenly, those exact same keys, which were often just sitting around in public code repositories or plain text websites, retroactively gained permissions to access private data.
Wait, what kind of private data?
We are talking about uploaded files and cached content from the generative language API.
Hang on a second. So the public name tag suddenly became a master key to the backend.
Pretty much overnight. And because developers had been actively trained for years that these specific keys were safe to expose, they were absolutely everywhere. Attackers could easily scrape public sites, grab the keys, and use them to access private AI data, or even run up massive usage charges.
That is terrifying. It is such a good reminder for anyone building systems that safe today definitely does not mean safe tomorrow, especially when the back-end infrastructure changes underneath you.
It perfectly highlights the immense danger of implicit permissions. And speaking of safety and permissions, we have to talk about the situation with Anthropic and the Department of Defense.
This is a heavy one. I know tech companies usually try to stay neutral, or at least they pretend to stay neutral.
Anthropic has taken a very specific, firm stance here. It is important to note they are willing to work with the U.S. defense sector. They are not pacifists in that strict corporate sense. However, they drew two very hard lines in the sand.
What were the lines?
Number one, no mass domestic surveillance. They cited fundamental civil liberties and democratic values.
Okay, that makes sense.
Number two, no fully autonomous weapons. Their argument there is purely technical. AI is simply too unreliable right now to be trusted with lethal decisions without a human firmly in the loop.
That seems entirely reasonable. Do not spy on everyone and do not let the robot decide who to target.
Well, the Defense Department took a different view. Their position is generally that if you want the lucrative government contract, you do not get to dictate the terms of engagement. They reportedly demanded Anthropic remove those specific no-go guardrails regarding autonomous weaponry.
And what did Anthropic do?
Anthropic refused. They stood their ground.
And usually when the Pentagon knocks tech companies answer the door, it is a massive revenue stream. It is quite rare to see a company turn down a defense contract on principle like that. But Anthropic is fighting battles on multiple fronts right now, are they not? Because they're also dealing with corporate thieves.
They certainly are. This brings us to the distillation attacks issue.
Distillation attacks. It sounds like they're out in the woods making moonshine.
In a weird way, they are extracting the pure essence of Claude. Anthropic detected that other AI labs, specifically DeepSeek, Moonshot, and Minimax, were aggressively querying Claude on an industrial scale.
So they were using Claude to train their own competing models.
Exactly. They were asking Claude highly complex questions, taking those high-quality outputs and feeding those answers directly into their own models as training data.
It is a way to bootstrap intelligence without doing the insanely expensive hard work yourself.
Yes. You are essentially stealing the brain patterns of a smarter, more expensive model to teach your cheaper local one.
It is like cheating off the smart kid in class, but doing it millions of times a second automatically.
And Anthropic is understandably not happy about it. They are publicly calling it out as a clear violation of their terms of service and a blatant theft of capability.
It really is the Wild West out there right now.
Yeah.
All right, let us lighten the mood a bit. I want to talk about lying to software for fun and profit. You mentioned Replit earlier.
I did. Replit built this incredible video rendering engine. The core problem they faced is that web browsers are fundamentally designed for real-time interaction. They are not designed to capture frame perfect video exports.
Right, because if the computer lags for even a millisecond, the browser just drops a frame to keep up with real time.
Exactly, which is fine for casual browsing, but terrible if you are trying to record a smooth professional video. So Replit decided to just lie to the browser.
How?
They injected a custom JavaScript virtual clock into the browser environment. They essentially constructed a matrix-style simulation for that specific browser tab. They intercepted the native date and performance functions.
So when the rendering engine asks the browser what time is it, Replit intercepts that call and says, do not worry, it is exactly time for frame 42.
Correct. Even if it actually took the physical computer 500 milliseconds to process and render that complex frame, the internal virtual clock only advances by exactly 16 milliseconds.
It completely decouples the rendering time from the actual wall clock time.
Yes, ensuring a mathematically perfect 60 frames per second export, regardless of any system lag.
That is incredibly clever. It forces a chaotic browser to act completely deterministic.
It reminds me of the way old video games worked, where everything was tied directly to the CPU clock cycle. And actually, it reminds me of another clever hack from a while back, the Twitter like button. Oh, the exploding heart. I love that animation.
Do you remember when they redesigned it back in 2015?
Vaguely, yes.
They wanted this complex, fluid exploding animation, but running that with standard vector code on low-end phones of that era was too heavy. So they went old school. They used sprites.
Sprites, like 1980s Super Mario Nintendo sprites.
The very same concept.
Yeah.
They took every single frame of that heart explosion animation and put it onto one giant image sheet, a sprite sheet. Then they used a very specific CSS steps function.
Steps. I do not think I've used that property in years.
It is a very niche property. Instead of smoothly sliding an image across the screen, it jumps instantly from one position to the next. So they just slid this giant image behind a small window frame by frame.
Like a digital flipbook.
Exactly. It was incredibly performant because the phone's browser did not have to calculate complex vector shapes or physics. It just had to move a static picture sideways.
I absolutely love that. Using 1980s arcade game tech to power a massive social network feature, it really proves that good engineering is timeless. It is always about using the right tool for the job. And speaking of highly efficient tools, there is a new standard gaining serious traction called dictionary compression.
Is this related to how we zip standard files?
Similar concept, but built explicitly for the web. Usually when you visit a website, you download a lot of repetitive text. Dictionary compression lets the server and the browser share a pre-agreed dictionary of known data beforehand. It is being integrated into modern standards like Brotli and Z standard.
So it is essentially like sharing a secret codebook.
Yes. So when the server sends you an update, say a massive new JavaScript bundle, it does not send the full raw text. It just sends references to the dictionary. Word number 45, then word number 102.
It massively shrinks the transition size because you are not constantly resending the exact same patterns you both already know.
That is a perfect way to put it. It saves massive amounts of bandwidth and speeds up the entire web experience.
That is so smart. It is like me walking into a cafe and saying to the barista, just the usual, and they know exactly what complicated coffee order was. I mean, instead of me explaining the milk ratio every single time.
Exactly.
Now let's move to the heavy lifting infrastructure topics.
Yeah.
Because I saw something about Node.js that made me do a complete double take. Having memory usage just by flipping a single switch.
It sounds like a scam, but it is totally real. It is called V8 pointer compression.
V8 being the underlying engine that runs JavaScript.
Correct. The team at Platformatic found that enabling this specific feature in Node.js cuts memory usage roughly in half.
How does it do that?
The technical detail is that it uses 32-bit pointers instead of 64-bit pointers for certain memory addresses, which just saves a ton of space.
Okay, I have to play devil's advocate here. If flipping a single flag in Node.js cuts memory usage by 50% with no apparent downsides, why was this not just the default 5 years ago? There has to be a trade-off somewhere.
It is a very fair question. The trade-off is the absolute memory limit. By restricting it to 32-bit pointers, you are strictly capping your heap size to 4 GB.
Oh, right. So for a massive enterprise monolith that breaks everything.
Yes, but for modern microservices running in tiny isolated containers, it fits perfectly.
So it is great if you are fully cloud native, but terrible if you are running a giant legacy beast.
Exactly. And because the garbage collector has significantly less memory space to scan, performance can actually improve. It means if you are running Node on Kubernetes, you can effectively double your pod density. You run twice as many apps on the exact same hardware just by flipping a flag.
It is literally free money for infrastructure teams.
It is.
Speaking of defaults, let us talk about Postgres, the database that basically runs half the internet.
Postgres. Reliable, sturdy. But apparently we have all been tuning it wrong for a very long time.
Not wrong, just historically. There is a deeply buried setting called random page cost. It tells the database query planner exactly how expensive it is to fetch a random piece of data from the disk. The default out of the box is set to 4.0.
And that specific number comes from the ancient era of spinning hard drives. Physical spinning magnetic platters where the physical needle had to physically move to find data. That was very slow.
But wait. The standard performance advice for years has been, if you are using a modern SSD set random page cost down to 1.1, basically you tell the database that random disk seeks are just as fast as sequential reads. Are you saying that advice is wrong?
It is not wrong for a local, directly attached disk, but it is very often wrong for the modern cloud. When you are running Postgres on AWS or Azure, your disk is not physically attached to your CPU motherboard. It is sitting somewhere else over the network.
So there is hidden network latency disguised as disk latency.
Precisely. A recent benchmark showed that in many cloud environments, the overhead of that tiny network hop makes random input-output much more expensive than we thought. Sometimes 25 to 35 times more expensive than a sequential read.
Wow.
So if you blindly tune for a local SSD, the query planner gets wildly overconfident and frequently picks the completely wrong index strategy.
So you think you're optimizing your database for speed, but the actual physical reality of the network cable is secretly slowing you down.
It is never simple, is it? You fix one bottleneck and the complexity just moves somewhere else in the stack.
It is the absolute law of software physics. But sometimes you can get it perfectly right. Look at Airbnb.
They did a massive database migration recently, right?
Massive. They moved their core key value store called Muscle from version 1 to version 2. Version 1 was having serious issues scaling, lots of operational headaches.
The usual, we built this custom tool 5 years ago and now we are entirely too big for it problem.
Precisely. So they completely re-architected. They moved to a new SQL backend with a fully Kubernetes native control plane. They implemented dynamic sharding so the database could automatically split itself up as it grew. And the absolute kicker, they did the entire migration with zero downtime.
Zero downtime migrations at that massive scale are the holy grail of infrastructure.
They really are. It required a highly complex event-driven write model and an unbelievable amount of careful planning, but they pulled it off flawlessly. It is a true testament to serious engineering.
You know, looking at all of this today, from block firing thousands of people because of AI efficiency to Anthropic fighting off corporate spies to Airbnb completely re-architecting their core data, it really seems like there's a unified theme here.
What is your takeaway?
Tools are getting much smarter, yes.
Right.
AI is writing the boilerplate code. But the human need to deeply understand the system as a whole is higher than it has ever been.
I completely agree with that. You cannot just be a syntax code monkey anymore. You have to understand how all the disparate pieces actually fit together. In fact, I want to leave you, the listener, with a thought about Jimi Hendrix.
Jimi Hendrix, the guitarist.
The very same. But I would argue he was also a brilliant systems engineer.
Okay, you are going to have to explain that one to me.
Think about it. Hendrix did not just pick up a standard guitar and play the notes written on a page. He mastered an incredibly complex signal chain. He had pedals, amplifiers, deliberate feedback loops. He deeply understood how the physical physics of the sound wave interacted with the raw electronics.
He manipulated the entire system to create a sound that literally had never existed before. He used the feedback, which is usually considered a critical error, as a primary instrument.
Exactly. He engineered the system. Developers today need to be less like typists and a lot more like Hendrix. Do not just write the syntax. Tune your signal chain. Understand the inputs and the outputs. That is where the real lasting value is.
That is a genuinely fantastic image. I'm going to go home and try to tune my own signal chain. Or, at the very least, try to fix my broken coffee machine.
Start small. Thanks for getting into all this with me.
Pleasure as always.
And for everyone listening, go out there and be a systems engineer. Catch you next time.
Spoken Tech for your ears.